Hello and welcome to this lesson on Android UI, where we cover views, view groups, and layouts. These are the basic building blocks for building UI in Android. The Android system and components allow us to build the UI we need per any specification using these basic building components. The View class represents the basic building block for graphical user interface in Android. In an application, each window or screen consists of views arranged in a single view tree. Each one of these views is assigned a particular area of the screen. Make sure to keep in mind that views can have overlapping areas so that one view may obscure another. Each view is responsible for drawing itself and dealing with event handling. This means that the view will receive a canvas used for displaying the graphics of the screen, and will be responsible in an onDraw method callback for drawing itself on that canvas. Also, callbacks for things like touch events, focus changes, and key events can be registered for a view, and the view will be informed when these events occur to it. Views can be hidden by other views, but even when a view is not covered by another view, it may not be visible to the user. Views have three visibility states: visible, invisible, and gone. When the view visibility state is visible, it will be shown to the user unless obstructed by another view, or the window containing the view is not being shown. When the view visibility is set to invisible, the view will not be visible to the user, but it can still take up space in the window that contains it. When the view's visibility is set to gone, it will not be visible to the user, and it will not take up space in its parent window either. Android has a wide variety of ready-made views that can be used in application development. These views can help build anything from utility applications to games and more. Let's take a look at some of the popular views used in Android. When adding text or editable text fields to an application, a developer can easily use the text view and edit text view components. Once a user enters data into an editable text view like an edit text view, they will normally need to inform the application when they have finished and that data is ready to be submitted to the application. In cases like that one and many more, buttons can be a very effective way for the users to communicate with the application and to begin a new action. Sometimes there's a need for a button type UI component that declares a Boolean state or value in the screen in Android. In this case, compound buttons like radio buttons, checkboxes, or switches can be a useful tool for presenting and allowing the user to edit this type of information. A requirement in many applications in Android is the ability to show images of one type or another. In that case, Android offers the ImageView class for the ability to display, manipulate, and evaluate images in Android. One of the most powerful view classes is the WebView class. It represents a customizable browser like View that can be used to display and manipulate remote or local web pages. When developing Android applications, it is important to optimize the UI of the application for highest performance. This is where the View stub comes in handy, by offering a placeholder view for less used UI components that can be lazily inflated. View groups are more complex derivations of the View class that are designed to contain other views. This is a base class for layouts and views like the scroll view and view pager. Another popular derivation of the View class is the adapter view group of classes. These views use a separate adapter object to determine the contents of each of their child views. They include views like spinners, list views, and grid views. Text views are a view that represents a basic text editor in Android. The text view class is pre-configured to not be editable, so that it can be used to display static text, labels for other UI items, and other text content in applications. The text presented in the text view can be predefined in XML or loaded dynamically during runtime. It can also be formatted to tailor to the design needs. When there is a need for a user to enter text into an application, the edit text class is commonly used. This class is a thin veneer and derivation of the text view class, which is pre-configured to be editable. It can also be configured to accept certain types of input like email addresses, passwords, and numbers. The button class in Android represents a push button UI component. Buttons can be designed to contain text, icons, or both. When it comes to buttons that contain icons, the image button class, which is a derivation of the ImageView class, can be used to offer more customization and control over the UI item. When a button is used in an application screen, the listener for the click events for that button can be set in the XML by configuring the onClick attribute of the button. This way, we can quickly add implementations for actions of the user pressing the button. Sometimes a button may be required to store information, as opposed to just representing a user action request. for instance declaring that a specific option should be enabled or disabled. In these cases, we have a set of compound buttons that can be in one of two states at any time, either checked or unchecked. Some examples of compound buttons include toggle buttons, switches, checkboxes, and radio buttons. When a compound button is pressed or clicked, its state will be changed automatically. In the case of radio buttons, they are commonly placed within a radio group, which governs over its children radio buttons, and when one is checked, it enforces that all others are unchecked. Image View is a view class used for displaying images. It has the ability to load these images from a variety of sources, like from the application resources or content providers. The image view is responsible for computing its measurements from the image so that it can be used in custom view hierarchies, and it also allows for easy scaling and tinting of the image. The scaling can be custom to center the image, crop the image, or scale the image. The WebView class in Android offers a view that can display web pages and is highly customizable browser-like view. The WebView can be customized to control certain aspects, like enabling or disabling JavaScript, dynamically having the WebView load URLs from your Java code in runtime, load content from local assets packaged with the application, or remote assets stored on web servers. By using custom WebView clients or Web Chrome clients, we can receive callbacks for web-related events like the progress of loading a web page, when any loading errors are received by the WebView, when a web page has finished loading, when a new URL is requested to be loaded. These requests can then be filtered and denied or accepted by the callback, when a form has been submitted, and much, much more. An important aspect of developing UI for Android applications is to ensure it has good performance and is as lightweight as possible. That is where the ViewStub view class is very handy. The ViewStub class is an extremely lightweight view that is initialized with no dimensions, is invisible, and is zero-sized. It represents a placeholder for a view that is rarely used, so that that view can be loaded on demand for better performance. When the view the ViewStub is holding the place for is requested, the ViewStub will replace itself with the inflated form of that view. When creating a ViewStub, its reference view can be easily assigned by defining the attribute Android:layout. Then upon demand, the ViewStub will inflate the reference view and replace itself with that newly inflated view. When designing screens for a variety of devices, we need to take into consideration that the same content will not fit on all screens. One of the useful tools for dealing with this constraint is the Scroll View class. The Scroll View is a layout container or view group that can be configured to either scroll horizontally or vertically by the user. The Scroll View can then be fitted to display large amounts of information for the user to scroll through, whether it be text, images, or other content. It is common to embed a linear layout inside of the Scroll View to easily organize items in the desired orientation. It is important to note that list views should not be used within scroll views, because that would constitute a redundant usage of the scrolling components. The View Pager is a popular view group class that is used for allowing users to flip left or right to traverse different pages of data and information. Each page will consist of its own separate tree of views, and the Fragment class is commonly used to accomplish this moderation. We will cover the Fragment class more in depth in a future lesson. In many cases, we will need to display lists or sets of data on the screen. The group of classes under the Adapter View Abstract class allow several different ways to display these chunks of data. Some of the view classes in this group are grid views, list views, and spinners. Grid views allow us to easily organize and arrange sets of data in a grid-like UI component. List views take the more conservative approach of arranging and displaying items in a horizontal list. When there is a need to have the user select an item from a list of items, the spinner view can offer a convenient UI component for allowing the user to make that choice. These views contain a set of children views which they arrange in appropriate order. These children views are determined by a separate adapter class that the adapter view relies on for controlling the data it will display. Now let's take a look at some of these views in Android Studio and see how we can implement them in our Android applications. In this part of the lesson, we've started Android Studio and created a new project called View Samples with an activity called Main Activity that has an XML layout called mainactivity.xml. This can be created in the same fashion as we did in earlier lessons. Now let's open the layout file mainactivity.xml. We notice by default that Android Studio creates an activity main.xml with a text view with the string hello world that we saw in the previous lesson. Let's switch to the XML view and see how the text view looks in XML format. we see that the text view has an auto-generated attribute called Android:text that defines the text for this text view. When we click on the text value of that attribute, we see that it changes to string / hello world because this string is actually taken from our strings XML. Let's switch over to our strings XML and change that value. As we mentioned in a previous lesson, the strings XML file is where we can store all of our string constants. Here we see a list of name value pair strings, including our hello world string. Let's change the name of the string to label and the value to this is label. Now let's go back to our activity main XML. We see that the text attribute is now in red because the name key of hello world no longer exists. So let's change that to our new name key of label. And then let's go back to our design view. We see that our preview for this value of the text view has also changed. Now let's add an edit text to our view for the user to input his email address. In the text field section of our palette, we see one for email, so let's drag and drop it into our view. Don't worry if it isn't in the exact position that we would like. We will fix that in the XML. In the XML, we see that the WYSIWYG editor has auto-generated a lot of code for us. Let's place this view below our text view and align the left of both. Okay, great. Now if we jump back to our WYSIWYG editor, we see that it is aligned and below our previous view as desired. Now let's add a button to the screen so that the user can submit their email. Drag and drop the button the same way we added the email input of edit text we had earlier. Now let's go into our XML and edit it to be below the edit text and aligned left. Great. Now let's create a callback for this button when it is pressed. We need to jump to the code for activity that loads this XML. In our main activity, let's add a function called formSubmit. It will be a public function with a void return value. In order to use this method as a callback for our button onClick call, it will have to receive the parameter of view. We see here that view is not a recognized class. By clicking on it and using the keyboard shortcut Alt-Enter, we can import that class so it will be recognized. For this lesson, we will create a toast-based pop-up to symbolize the user submitting his email to the application. In order to do that, we need to get the value from our edit text, so let's set that up through our onCreate. You notice again that we have the red curly line, signifying that we have not typecast our view to an edit text. We hit Alt-Enter, and then we can select Edit Text to save our view in the email member of our functions. Now, in the form submit, all we simply need to do is get the value for that and post it in a toast. Now that we've created our toast, we simply need to show it so that the user can see the email that they have submitted. Toast can easily be created by calling this method, makeText, on the toast static class method. The first parameter we need to give the toast is context in order to display the toast from our context. We can easily get our context from the view that is submitted on the button click. We then need to get the text that we're going to submit in this toast. To get the text, we call the getText function on our email, which returns an editable, and then call the toString function to get text from that editable. We then have to give the third parameter, which is how long to display the toast for. We'll give it length short for toast, and then we will show that toast. Now we need to jump back into our XML to add the onClick attribute to our button. In the XML for button, we add the attribute onClick, and now we can add the method we previously created, formSubmit. When we run this application on our emulator, we'll see that on every click of the button, the formSubmit method will be called as a callback. Now that we have the application running in our emulator, we can enter an email address and press our button. And we see that our toast is created at the bottom. And this is all from our callback that we declared in our main activity Java and also declared as an attribute on our button onClick. Thank you for joining us in this lesson about views, view groups, and layouts. Join us next time when we visit the topic of event listeners, like our onClick callback.